Hello and welcome to CUDA Weekly. I'm your host, Johan Bontes. Now, we've done Hello World last time, but when you run it in Compiler Explorer, you may sometimes find that it doesn't print. Now, why is this? Let's talk about it. Okay, so here we have the same code from last time. It prints output from the GPU and it prints some code from the CPU. Now, when we look at the output, we can see that it only has output from the CPU. The program compiled okay, it ran okay, but, well, the GPU code didn't actually run. Now, how is this? Well, we can easily fix this by specifying the actual architecture that the GPU is running on. And when we do this, we can see that, yes, now our GPU code runs and it actually gives output. But how would we know which architecture to actually list? For that, we need to copy paste some code. Okay, we have some output here stating that the device that's running underneath Compiler Explorer is the Tesla T4, device capability 7.5. This matches the architecture 7.5. And then there is some info about the clock rate and some other info about memory and other limits on the device. Okay. So this output comes from a host function here. Host means it runs on the CPU. Then we have a macro, some host device code. Host device means it runs both on the CPU and on the GPU if we ask it to. But then, well, we've cheated a little bit because we have a macro here saying CUDA architecture. If it runs on a CUDA device, then we execute this code. If not, then we execute this code which runs on the CPU. So here's the GPU, there's the CPU. Then we have a device function, device meaning the GPU, and this simply exits the current program. Okay, let's go back to the print device function. First, we ask CUDA how many devices are there on this machine to see if we have a GPU at all. And then we enumerate all these devices and ask for the device properties using the CUDA device properties. There's a whole bunch of them. And we print them out in turn. This function here puts its output in a prop record, and it returns a status code. All these CUDA functions all return the same status code, and we can check this using a macro. And this macro calls the CUDA search function. If that status code does not match CUDA success, we query it, get out the code and the file and the line where this error occurred. Now on the GPU, that's pretty much all we can do. But on the CPU, we can actually get the error string using CUDA get error string and get the file and the line. Now, unfortunately, this file and this line doesn't actually list the error position on the GPU. This one does. But it lists the error on the CPU. So it's less informative than it could be, but it's better than nothing. We can force an exit from the device using this little snippet of code here. The CUDA arc is interesting because we can actually use this to find the architecture that this executable was compiled for. Not the one it runs on, but the one it actually was compiled for. And that we can use to query a number of things. Now, I would like to print this, but I can't do this directly because C++ doesn't allow us to do that. So with the help of two helper macros, I can actually force it to print it. There we are. And then we can do something like this, where we say, okay, we have an architecture, a string, and then we stringify the CUDA-arg parameter. When we do this, we can see, yes, it's 750, and this matches. Now, when we change this parameter, the T4 only allows us to go back a little bit. It will allow us to go back to 7. Okay. But when we set it to 60, well, then it refuses to run. The reason for this is that the 70 architecture has a different way of meshing these threads together than the 60 does. And the T4, to keep it simple and cheap, doesn't actually allow this backwards compatibility. There are other cards that do allow it, but the T4 doesn't. Now, when you omit this parameter on CUDA 12, it is set to 5.2, which is the oldest GPU that particular version supports. And that's the reason why out of the box, it doesn't actually run this GPU code. So we need to specify it explicitly, and then everything works. I would like to leave it there. Thank you for watching, and I'll see you next week.